All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 1.1 in Algebra 2. We're going to start with example 1, which is on page 5 of your Algebra 2 textbook. So I'm going to read it instead of writing the whole thing down to save my sanity a little bit, and also hopefully you have the PDF or a book in front of you. So an attorney charges a fixed fee of $250 for an initial meeting and $150 per hour for all hours worked after that. Part A, make a table of the total charges for 1, 2, 3, and 4 hours worked. Okay, so again, let's write down the important takeaways from this, right? So a fixed fee of $250, okay, so $250 fixed fee, okay, and then we heard $150 per hour for the hours worked after that. Okay, so mental note should have been a lawyer. Okay, so let's make a table of this information. So now, I'll be honest, I wouldn't actually do this problem in the order that they're suggesting that you do it. I would jump right to making an equation because I'm a math teacher and that's how we roll. But we'll go ahead and make it a table first. Okay, so we'll talk about the total hours worked, right? And then we're going to talk about how much the fee is or how much the cost. So if they work no hours, and they actually didn't say put 0 on here, they said 1, 2, 3, and 4, but that seems silly, so I'm going to put 0 on here too, despite the instructions. Okay, so if they work no hours, but you have an initial consultation, like you walk in that door and change your mind, you're still paying the $250, right? So you're paying the $250 just for walking in the door. If you walk in the door and then work with them for an hour, you have the $250 flat rate that you paid, plus the hour, so that would be $400, right? For each additional hour, you pay another $150, so this would be $550, right? This would be $700, right? And this would be $850, right? Whew, not cheap. Okay. Part B, graph the points represented on your table and connect them. So part B. Now I'm going to try and pick a scale that doesn't make me totally miserable. So I'm probably going to go by hundreds on my y-axis, right? So my x-axis, right, my x-axis, we'll call x hours worked and we'll call y the cost, right? So my x-axis should be the independent variable, right? And the y-axis should be the dependent one. The cost depends on the time, not the other way around, right? Okay, so we went up to 4, so 1, 2, 3, 4, right? We're going to go, let's just do that. So 1, 2, 3, 4. Okay, so I'm going to make this go by, so this is going to be, we're going to go by hundreds, right? So this is 100, that would make this 500, that would make this 1,000, okay? And this is going to be cost in dollars, right? And this is going to be hours worked, okay? All right, we are back to graphing after an interruption by a spam phone call. So, I have my independent variable time on the x-axis. I have my dependent variable cost on the y-axis. I've scaled my axes consistently. So I have a spot at 0, 250, right? 1 and 400, 2 and 550, which is sort of in that neighborhood. 3 and 700, which should be about there. And 4 and 850, which should be about there, and then I'm connecting the dots. Now, it should look linear, meaning it should look like a line. My graph isn't perfect. One of the things that you'll notice as we move forward in this course is realistically, you're never actually going to be asked to graph by hand for the rest of your life in a way that matters because there are computers and calculators, and really graphing by hand should not be a deal breaker. So do the best you can when you're graphing by hand, but it's certainly not a big deal. Cool. All right, part C. Write an equation, a linear equation to model the situation. So we discussed in the first video in this section, even though we really weren't supposed to go into different equations, we discussed that slope-intercept, y equals mx plus b, is particularly useful for most word problems because very often we have some sort of initial fee, right, which is our y-intercept, and we often are given some rate, and usually the hint is the word per, and that's usually my slope, right? So because that's the change that I get between every single one of these values. So sure enough, in this situation, that's exactly what's handed to us. We are given a fixed rate, an initial rate of $250, right? And then per hour, we pay $150. So it's going to be y equals 150x plus 250, which is the flat rate or the initial fixed fee. So that's my equation, right? And then lastly, part D says, use the equation to find the charge for 25 hours of work, because you don't really want to sit and have to add over and over again up to 25 hours. So we're going to go ahead in part D, and we're going to use that equation. So we're substituting x equals 25 hours. So y equals 150 times 25 plus 250, right? And when I clean this up, I end up getting that this is $4,000. So yikes, 25 hours, $4,000. Lawyers are not cheap. Okay, so that's example 1 on page 5. And what you can do if you want a little bit of practice is there is a practice problem right below that that says try this, where they discuss a water tank already containing 55 gallons of water and then being filled. So if you want to try a problem that is similar to that one, pause this video for a second and then give a try to the practice problem that is directly below this one. And while you do that pause, I'm going to go ahead and erase, and then I'll walk through the practice problem. All right, so I'm going to call this P1. It's the try this that's directly below E1, so I'm going to go ahead and read this to you. A water tank already contains 55 gallons of water when Darius begins to fill it. The water flows into the tank at a rate of 9 gallons per minute. So part A, we're going to make that same table. Part B, we're going to graph this table, the points, and connect them. Part C, we're going to write a linear equation, and part D, we're going to find the volume of the water in the tank at 20 minutes. So a thing to keep in mind is if I were really having you do this past section 1.1, I would entirely skip steps A and B. I don't really care that you can make a table, and I don't really care that you can draw a graph by hand. Both of those are skills that you could make a computer or a calculator do. What I do care that you're able to do is write an equation from a situation given in a word problem, and then use that equation for other things. So again, really, to me, it's steps C and D that matter more. So let's go ahead and walk through them. Again, it's important to note that it's steps C and D that matter. Now, I'm not saying the other steps aren't important, but again, realistically, you're going to use computers and calculators to make your tables and to make your graphs. That's what Excel and other programs similar to that are for. You're just not going to be doing this by hand in the real world. So, but let's go ahead and do our table in A, right? So we have minutes, right? And we have gallons. So at 0 minutes, there are 55 gallons already in the tank, right? And then at every subsequent minute, right, every minute after, we gain an additional 9 gallons, right? So at minute 1, you would add 9 gallons to the 55 and you would get 64. And then at minute 2, you'd add 9 and get 73. And at minute 3, you'd add 9 and get 82. And at minute 4, you'd add 9 and get 91. Okay? I'm asked to graph this. Again, totally annoying, but it is what it is, right? So if I graph this, looks to me like I want to have a scale that probably goes up as high as 100, so I'm probably just going to go by tens. It doesn't have to be the most accurate thing in the world. So here's my 1, 2, 3, 4, and that's going to be minutes, right? And then I'm going to go by tens. So let's call this 100. Right? The easiest way to get tens is to cut it in half. That's 50. And then you take a chunk out of the middle and then cut the halves in half. And that'll make it go by tens. So, and that is gallons, right? So, 0 and 55 would be somewhere around here, right? 1 and 64 would be somewhere around here. 2 and 73 would be about here. 3 and 82 would be somewhere around here. And 4 and 91 would be somewhere around here, and then there's my line. Again, it doesn't matter to me if you're not awesome at graphing by hand. Part C and D are the ones that really matter, right? So for part C, I know that I have y equals mx plus b. I'm looking at a linear equation. Well, I was given a starting value of 55 gallons, and I was given a rate of 9 gallons per minute, right? So the trick here is that usually that per word tells you what your slope is. So my equation is going to be y equals 9x plus 55, where y is the gallons and x is the minutes. Right? It's worth using, writing down what my variables represent here, especially if you use variables like G for gallons and M for minutes, then it's less of a big deal, but I would avoid using M as a variable because M is also the slope, so that gets a little bit dicey. All right, so this is my answer to C. Last thing I'm going to do is use my answer to C to find the volume of the tank after 20 minutes. So my answer for D is going to be when X is 20 minutes, I'm going to get Y equals 9 times 20 plus 55. Well, that's $1.80 plus 55, so that should be 235 gallons. That's assuming that the tank is large enough to accommodate 235 gallons, but we're going to go ahead and assume it is. So Again, there's your E1 and P1, and then in the next video, we'll go ahead and do E2 and P2.